stage? Thanks for coming. This is very strange hearing myself on the microphone. Usually I project. Am I yelling? No. All right. I might. Just so you're aware. Movement in mind. Movement in mind. The question is, what impact does physical activity have on learning? So you know you have to stand up, right? Everybody, stand up, stand up. So as you're standing, think about what types of movement would a child typically experience in their school day and in the classroom. Ready? Hands up. Exhale all the way down, as low down as you can go. Inhale back up. Exhale, low down as you can go. I'm mic'd, so I can't do it. The wires are doing weird things. Inhale up. Exhale all the way down. Nice. Inhale up. Baby back bend. Ah. Back down. Inhale, get tall. Exhale, twist to one side. Keep going. Keep going. Nice. Few shoulder rolls. So now that you're moving, shout it out. What sort of things do you think a child would typically do during the day? Sit! That's right. Have a seat. Thank you for playing along. So now that you're all awake and ready to learn. Yeah, certainly sitting. There's recess, maybe. There's moving around between classes. There's what else? Handwriting. Eye movements. There's even circulation, movement, your heart, your lungs. And if you're sitting down slouched over like this all day, your lungs can't expand. You can't get that circulation going, right? So we'll talk about a few of those today. So one question, let's start with handwriting. What role does handwriting play in the 21st century? I mean, keyboarding is certainly a practical skill, but handwriting, like in your life right now, what role does that really play? So researchers gathered together in 2012 to pool their findings to answer just this question. And the results were kind of surprising because I was like, who cares? I type all the time. I can't read my own handwriting. Nobody else can read it. What difference does it make? Basically none, right? Go ahead and read that to yourself, please. Close your eyes. What did you read? It took a while, did it not? It took a while. So basically, because your brain spent so much time trying to figure out what this was, what the words were, that you didn't have time to think deeply about what you were reading. Because had I just written that normally, you would have just read it very quickly, which is my mother, who she is. My mother is visiting me for a few lovely days this month, and I will take her to see the fall foliage. That was not fluid, that was not automatic, right? That was a lot of trouble. This is similar to what a child would experience if their handwriting is not fluid or automatic. So their brains would spend so much time trying to write the word that they're not thinking as deeply about what it is they're writing. And this actually shows in brain scans, in functional MRIs, and standardized test scores, believe it or not. Some other researchers from UCL and Princeton wondered about the efficacy of note-taking on a laptop versus longhand. Does anybody hear this? This has been on, this is on a few radio shows and things like this. So what they did was they had a group of students, naturally, right, watch a TED Talk. Half of them took notes longhand, the other half on a laptop, and gave them a test immediately afterwards. The test had factual questions as well as conceptual ones. So with the factual questions, the longhanders and the keyboarders did about the same. But with the conceptual questions, the longhanders did much better, like half a standard deviation better. Even though the keyboarders typed about 50% more notes, and they typed things mostly verbatim. Then they did it again. They did the same test again, but this time they took the notes during the talk, went away for a week, came back, had 10 minutes to review the talk, to review their notes, and then took the same test. This time, who won? The longhanders kicked the keyboarders' butts this time, hands down, in both the factual questions and the conceptual questions. So it could be that there's some bit of processing that has to happen while information is being presented to you in order for you to learn more effectively. Interesting, huh? Who doesn't smile when you see this guy, right? Richard Simmons. So other forms of movement that you would typically see, recess, exercise, things like that. We know, and we have for a while, that most modern day chronic ailments, heart disease, osteoporosis, many things have one thing in common. Almost all of them do. Can you guess what that thing is? Inactivity, that's right. So throughout the vast majority of human history, we were not sitting down. We're not in recliners, right? There's no refrigerators, there's no cars, there's nothing like this. So we were outside moving around all the time for food, for shelter, for anything you needed. You couldn't be still. And our brains evolved along with our bodies, right? Say right. That's right, that's right. So John Brady, professor of neuropsychiatry at Harvard Medical School, said this in his recent book, Go Wild. Sedentary behavior causes brain impairment, and we know how. By depriving your brain of the flood of neurochemistry that evolution developed in order to grow brains and keep them healthy. Bonus points to anybody who knows what this molecule is. Come on.
Chocolate.
Close, close. She says chocolate. Caffeine! There it is. It's caffeine. Yeah, there you go. So the way science, medical science work now is first we look for a correlation, and then we find the cause. We find the biological steps that links A to B. And we've done this with many things. We've done this for smoking causes lung cancer. But we've also done this for inactivity causes brain impairment. It's done. And I'm painting all this science with very broad strokes, so you'll have to bear with me here. Let's talk about the science of what happens in your brain when you're moving. So neurotransmitters, these chemicals that influence how one neuron communicates with another. There's a bunch, and they work in these giant feedback loops. We have pharmaceuticals, we have drugs that can influence one, maybe two, like Prozac influences serotonin, or Ritalin influences dopamine. But we don't have one that influences effectively the entire loop, the entire feedback loop altogether to make the whole system better. No drugs. But we do have something that does, and what is it? It's exercise. I'm sorry, I'm yelling. Of course it's exercise, you know it. When we learn new things, like this word, this is my favorite word, defenestrate. And if you don't know what it is, well, if you understand it, then you'll know where there's a picture of a window there. Otherwise, look it up later, defenestrate, my favorite word. When you learn something new, your brain will fire certain neurons in a certain circuit. If you never revisit that, then what happens? The connections they're not maintained, and you forget. But if you practice, if you revisit over and over again, then those connections are maintained, they're strengthened, and you remember, you've learned something. Of course, there's more neurotrophins. These are other chemicals in your brain which make your brain stronger. They're basically fertilizer for your brain, especially this one, the brain-derived neurotrophic factor, BDNF. It not only makes the neurons stronger, but it grows new ones. Isn't that awesome? This is awesome. Come on. This is great news. We have this stuff. We can actually make our brains better. Especially in the hippocampus, which is the area of the brain associated with memory and learning. But of course, there's more. So we can build this new circuitry. And how do we actually build it? Actually, I should have mentioned that a second ago. What could actually make some more of that stuff? Exercise. That's right. Do we have a pharmaceutical that can do this? Of course not. We would take it, we would all just eat it all day long, right? To make new brain cells? Of course we would. Nothing can do it, but we do know it can do it. Of course it's movement. Movement does it. So we built some circuitry, and now we need a stimulus. So we have this new brain cells happening, but unless there's something to learn to reinforce all that stuff, it's just going to go away. So we can actually change our brains. You know, we used to think they were fixed, and you were born with whatever you were born with, and that was it, and this is how they would scare you away from drugs and alcohol as a kid, because you're going to kill all your brain cells. And I'm sitting there, no, I'm already dumb, just like my brothers. I don't want to do that. But in fact, that's actually not true. Our brains will adapt. They will adapt to our movement, or they will adapt to our stillness. So we get to decide, use it or lose it. So we know physical activity has been shown to do a whole host of things, which we all know. After you take a brisk walk, you feel more energetic. You feel better, right? We know this. It also leads to lower body fat, to regulate hormones, things like this. And I lost my train of thought. Anyway, the American College of Sports Medicine put out this paper this year. It's a position stand. So what they did was they took about 6,000 different papers about all of these things: physical activity, fitness, cognitive function, academic achievement in children, and tried to synthesize them into one position statement, which is almost impossible. I mean, if you just think about what's the definition of being physically fit for a child? Well, I don't know. How do you even define fitness or movement? So just the other day, I took a walk with some students, and some of us sprinted, some of us kind of skipped along, and others lollygagged. I mean, how do you measure that? How do you measure all that quantitatively and put it all together? So this is a very difficult thing to do. So they started with about 6,000 papers and ended up with just a few hundred. But in there, they had some very interesting results. The first point they made was the one that I just did, that synthesizing all this information is exceedingly difficult to do. But delivery of physically active lessons generally results in improvements in academic achievement, whereas attempts to increase activity in PE do not. So PE is great. It's got a whole bunch of awesome things that work very well, but there's something about movement during the day and during the lessons that really helps brain function. So a little anecdote for you. A teacher of ours at Summit School, who's actually here today, Catherine Mills Hernandez, noticed a while back, she's a language arts teacher, she noticed a while back that when she had movement in her class, the students seemed to do better. They had more thoughtful questions, even their scores are better, their test scores are better, everything was better. And she noticed this because she's a practitioner of what's called the workshop method for teaching language. So all the students would gather in a small group on the floor, and she would talk to them for about 10 minutes, and then they would break off in different groups. And so they were, every now and then, they'd be moving around the room. And she noticed that after those transitions, the students seemed to be a little bit less lethargic, a little bit more engaged. Then after doing some work, some research rather, she took it up a notch. And they started actually doing jumping jacks or running in place or doing some stretching or getting silly or running up and down stairs or something like this during and before the lesson, and that's when things got even better. But we all knew this to be true from our own experience, right? You take a brisk walk, do you feel better? Yes. Everybody say yes? Yes, thank you. Okay. Another point that they made, which is very interesting, is that through all of this physical activity, all of these things were the vast majority were great. Movement was great for all of these things, not only for your body, but also for your mind. A few were neutral, and there was nothing that was bad. There was nothing that was bad about movement during the day for kids, which is this a surprise? No, this is not a surprise, we know this. So once again, attempts to increase PE have a neutral effect on academic achievement. It's very good for other things, but not necessarily academic achievement. They also make the point that changes in public policy are likely needed to systematically provide incentive and direction for increasing physical activity in elementary schools, which is probably true, right? Let's talk about ADHD for a minute, attention deficit and hyperactivity disorder. We all know folks, or perhaps we have, ADHD, right? So these folks have a lot of trouble focusing, or they have this laser focus, and they procrastinate. It's hard to start, hard to get things done. One thing that seems to work very well is complex movement plus heavy exertion. So jogging for them is great, but running on an obstacle course with a whole lot of things to navigate is way better because you have that component of concentration as well. And there's a bit of danger. So it could be ballet, it could be skiing, martial arts, gymnastics, whatever it is, so that you have to pay a lot of attention to what you're doing. You're exerting yourself a lot, but you also have balance and timing and fine motor adjustments, and there's that danger. So you don't want to get karate chopped, and you don't want to fall off the balance beam or ski off the cliff or whatever it is. So that combination seems to have really good results with folks with ADHD. And also, more generally, the exercise does create stronger neural connections and boost cognitive skills, which does translate into facilitating learning other things like math, like language, like anything else that you want to do. So what can we do now? Well, I can tell you what we do at Summit School. We just move. This is not rocket science. You just move. Like, you have to tell a kid to stay still, right? If you don't tell them to stay still, what are the chances they're going to stay still? They're moving all the time. So we do have an hour for lunch and recess. We do have PE, but we also have, we take movement breaks with the whole school coming together. We sprint and do some stretching. Sometimes somebody wants to do push-ups or something like that. That's awesome. And then we meditate for a little bit. But the teachers also, whenever they want, they can take their whole class for a walk. They can just stand up, they can move around, they can stand, they can sit. They can just move around, and it shows in the energy levels. And the kids tend to be engaged for so much longer because we all need a break, right? You're all sitting there like, yeah, we need a break now. So one of my favorite biomechanists, I have a favorite biomechanist, I'm that big a nerd, Katie Bowman. She has a million different ideas on how to get kids up out of their seats. Up out of their seats and moving around. So bottom line, movement, yay! Stillness, boo! Movement, yay! Stillness, boo! So really, we all know this. We can all easily incorporate more movement into our day. We don't know things like exactly what does the movement have to be? What is the type? What is the duration? We have no idea as of right now what we need. But so what? We can still move. It's like, vegetables, like vitamin A. I have some vitamin A requirement every day. I don't know exactly what it is. It depends on my stress and what else I ate and all these other things, but who cares? I know I need to eat more vegetables and that's good for me, right? So we can still do something without knowing all the little details. Just get up and move more. Done. No problem. So we are really biological creatures. And we've evolved moving. So movement is very good for our bodies, but in particular, it's very good for your brain. Thank you. Now you have to stand up, move around. Come on.